So now next comes to our last two control pin. One is a S1, another is a S0. So these two control pin are produce the different type of status signal for 8085 microprocessor. So this is called the status signal. This produces the status signal, different type of status signal for 8085 microprocessor. So what are the use of this status signal, these two status signal? So to represent the different type of machine cycle in progress, we use these two status signal with the combine of input output and memory signal. So by combining these three signal, we can generate different type of status signal for different type of operation in 8085 microprocessor. To represent, use what is the use of these three? So this to represent the different type of memory cycle in progress. To different type of memory cycle in progress, we use this combination of these three status signal and produce different type of status signal for the different type of operation. As you can see, this is a memory cycle. So memory cycle, what is memory cycle? We will discuss this memory cycle in detail in our coming session, but let's see what are the memory cycle available in 8085 microprocessor. There are 5 memory cycle available in 8085 microprocessor. So what are the 5 memory cycle? First one is a memory fetch. Second is a memory read. Third is memory write. Fourth is input output read, and fifth is input output write. So these are the 5 machine cycle available in 8085 microprocessor. To execute the time, we will see this 5 machine cycle when we will draw the timing diagram for the each and every instruction. So at that time we will see this all the machine cycle, and as you can see, these two are the memory related read write operation, these two are the input output related read write operation, but this first one is quite new to us. So what is a fetch memory? As you can see, memory fetch, what does it mean? This means that this signal means microprocessor is fetching this signal means what? This signal means the microprocessor is fetching this signal means the microprocessor is fetching the address or pointing the address. That means we'll see this thing in detail in our coming session. So before discuss this thing, it needs to talk some other thing also. So now that's why I am now directly drive into that. I am not driving into that session. Just remember this thing, that microprocessor is fetching the address or pointing the address. That means program counter always hold the initial address. It will place that address to the address bus. Then address bus will start to point a particular address or location into the main memory, and from the main memory the instruction will be retrieved or will be read and placed to the data bus. That is the process actually. So we will discuss the process in a coming session, so that would clear your idea for the fetch operation. So as well as we also discuss this one in our coming session where we will draw the timing diagram that I have also said. So this is a fetch operation and this is a definition. regarding to the fetch operation. So as I have told you that by combining these three status signal, we can generate different type of control signal. We can different type of control signal for the different type of operation. Let's draw the chart first and see what are the control signal that you can generate from these three by combining these three status signal. So let's draw it. So status lines are there. So this is the input output memory. S is status. This is the thing. Let's make it. So now we want to perform the memory related operation. Then what we will do, we will put 0 here. So let's put 4 0 back to back here. So that means we want to perform 4 memory related operation here. So that will be 0 1 1 0. That will be what? 0 1 0 0 0 1 1 0 and 1 1, and that would be not the 0, that would be the first is Z that you can see here. So let's see what is the code, what this particular code of the status signal is defining which operation. So as you can see, this is a Z here. I have put, this means that high impedance state, high impedance state. As you can see, 0 0. So this S0 is quite relevant to read operation, and this S1 is quite relevant to write operation. So when we will perform some operation, we will decide those operation in the basis of read and write. So that would also help you to understand that operation, which operation it is going to perform. So this is Z, this is a high impedance state that you can see here. So this Z 0 0. So this signal, if the three status control pin will have this 3 signal, so then it will produce a operation which is called the halt, That means that stop execution, the execution which was going on for the each and every instruction. So that execution process will be stopped when this 3 control pin will generate this particular signal, that is Z 0 0. So when this 3 control pin will get this particular code, then the operation will be performed halt. And the second one, as you see, this is a 0, that means it's obviously a memory related operation. This is 0, that means it's, I have told you, this just it relate to the read signal. So as you can see, 0, that means read bar will activate, read mode or read signal, right, extreme. So write signal will be activated. As you can see, 1 is here, the read signal will be deactivated. That means the status signal will be memory. Here it's a memory, here is a write, so memory, write, so memory, write, or you may say M write. Here is also the memory operation, as you can see, 0, but here is 1, that means the write operation will be deactivated, but 0 here, that means read operation will be activated. So at that case it is a memory read operation will be performed. As you can, it is also a 0 0 here, that means it's a memory related operation, but both are the 1, that means no, not the write, not neither write nor read operation will be activated. So at that case, this code define a important machine cycle, which is fetch. This is a memory related operation. As I have told you, the fetch operation will be performed. That means when the status 3 status signal will generate this code 011, and that case the microprocessor will understand that it needs to perform a fetch operation. So that's what the 4 operation related to this thing. So let's perform more one. Another is 1 1 1, and then in this word will be 0 1 1 0 and 1 1. So as you can see, as I have put here the 1, that means it's the input output related operation, and this is a 0, that means write bar will be activated, and this one read bar will be deactivated, that means input output write. As here the input output operation, but 0 is here, that means read bar will be activated, and that means IO read. Here is a 1 1 1. What does it mean? So there is neither read nor neither write nor read operation will be performed. So when this kind of code will be generated, so this code is called INTA, which is an active low signal. INTA, so we have told you in the previous architecture of 8085, we have seen that interrupt control block. So the block which was helps the microprocessor to set up a communicate with by the external device. So we have seen that INTA signal, so interrupt acknowledgement signal. So when that means when the microprocessor will produce, when the timing and control, when the timing and control unit will send this 3 signal, will get these 3 signals, so that case it will start to perform the intra operation INTA, and we will see in further more detail what is the INTA. It has a great significance when we will see the executions of the operations of non-vector interrupt. At that case we will see it has a great significance. So that is the intra INT interrupt acknowledgement. And the next 2 signal, one is a Z. This 2 signal is not quite, it's completely resembles to each other. One is Z, XX, don't care here. When the control signal will get that kind of signal, that means this is a high impedance. Sorry, impedance. Get that kind of signal. So at that case it will perform the hold operation that I have seen. Hold operation in our previous video during the operations of DMA, direct memory address. Direct DMA also send these hold signals to the microprocessor to access all over the data and control address and data bus. So this is a hold operation when it will perform when this kind of signal will be generated in that 3 status control pin. And the last one is the Z1 also, XX, XX. So these 2 are same, and when this kind of will operation perform, the reset operation will be performed. So here you can see that this is for the hold, this is for the hold, and this is for the reset. As I have told you, when DMA related signal will be performed, that case this signal is valid. When DMS is not relating to the any DMA related signal is not performing, at that case if this signal will be produced, that means that will be signify the reset to the microprocessor. If DMA is not connected to the microprocessor and the signal has been produced, so at that case it signifies that it will signify the reset operation needs to perform. So these two operation we have seen in our previous video, the reset, all the data will be initialized. So that was the control complete chart of the status signal. So by the three combination of status signal, what are the different type of control signal that you can generate, as you can see over here.